Hey there! Welcome to today's video where we're going to tackle a common problem that many people face. The problem at hand revolves around a question that needs to be more focused, hence it's currently closed and not accepting any answers. Now, let's dive into the solution for this issue. You can use the polyhedron constraint, which specifies that the end effector pose should be within a polyhedron, creating a linear constraint on the end effector position. This constraint will add a nonlinear constraint on the generalized position Q by linearizing this nonlinear constraint. For example, using the eval function with autodiff, you can obtain the linearized version of the constraint. In addition to that, when linearizing the dynamics, you have a choice to make. Do you linearize once per MPC loop at the initial state, or multiple times per MPC loop, once at each collocation point, utilizing values from the initial guess? If your system is control affine, then it may not matter what U is being linearized about. If you already have a trajectory in mind to follow, it's suggested to linearize at every dt around the future state on the track trajectory. Otherwise, you can opt to linearize around the current state. In summary, we've discussed a practical solution to the problem of adding linear Cartesian constraints to the end effector position. Remember, focusing on narrowing down your question can greatly improve the chances of receiving helpful answers. Thanks for watching, and if you found this video useful, don't forget to subscribe, like, and share your thoughts in the comment section below. And as always, keep coding and stay curious.